Hello everyone, my name is Jayaprakash Ramakrishna and I'm the VP of QA practice at Xoriant. Today we are going to be talking about the performance engineering overview and why performance engineering. Before we get started, let's have a quick view about our company, Xoriant Corporation. 21 years of experience working in full life cycle business application management, including development, testing, support, and migration. We are one of the third largest independent offshore testing service providers. We have offshore locations in Mumbai and Pune back in India. We cater to all verticals, starting from end-to-end testing as well as multiple alliance with test tool providers. We run testing as managed services for the total end-to-end testing, ownership through our global delivery, on-site, offshore, and hybrid models, and we do also have nearshore model. We have a very well-established, ready-to-use framework and industry-specific center of excellence. So for more information, please go ahead and check out us at www.xoriant.com. So let's quickly get started on performance engineering. So before we actually get started with the performance engineering for today, for this presentation, I want to use a healthcare example. Since most of you have already heard about Obama Healthcare, I just want to take that as a preview of having that as an example for the rest of our presentation. So you must have already heard about the Obama Healthcare performance issues, like the fiasco that happened where millions of people were trying to log on, but then again they had issues even getting onto the website. And one of the main reasons that it happened was because the product was not able to scale. The software was not scalable. And it was for various reasons. One was the infrastructure, the application was not well tuned, and it was not well tested to cater to the actual business demands of the end users. So let's keep that as an example and let's move forward with performance engineering. So what is performance engineering? So again, so this gives you a pretty much a snapshot of how most of the applications are deployed in the cloud or even in the hybrid model. So we have the end users, we have the internet, and again, this is one of the simplified version of our topology of the software deployed looks like, right? And then you have load balancers, we have web servers, application servers, and database. And of course, in addition to these things, there would be a lot of other components which I have not really put in over here to keep it more simplified. So what is performance engineering? Again, the book definition about performance engineering is basically performance engineering encompasses the defined set of roles, skills, activities, best practices, tools, and deliverables applied at every phase of development life cycle to ensure that the designed and implemented solution meets the functional and non-functional requirements. Again, when we talk about roles and skills, the roles and skills could mean that the actual people involved, it could be the business analyst, it could be the performance engineers, the QA functional resources, the architectures, and the actual end users, right? So, and the activities are basically what you do as part of your activities in terms of architectural reviews, code reviews, making sure the business requirements are very well translated into a software components, and also defining the business requirements in terms of transactional throughput. When I say transactional throughput, it basically means that when we are actually building a system, we need to be very cognizant about the fact that the system should be able to use or cater to like about 2,000 or 1,000 transactions per hour from a business transaction, not the throughput from a kilobytes. So, and again, there are various tools that we use at the different stages of our software development life cycle. And one of the main objectives and the benefits, again, is also to increase the business revenue by ensuring that the system can process the transactions within the requisite time frame, eliminate system failures, eliminate avoidable system rework due to performance issues, and eliminate tuning efforts at the later stage. Most oftentimes, again, people deploy, and then when they are in production, that's when they realize that they have issues, and then the cost of fixing an issue when you are in production in the fire reporting mode is a lot more expensive than when you try to identify them in a preventive mode. And of course, it definitely is better to avoid additional and unnecessary hardware acquisition costs at the later stages. And production downtime, it definitely reduces production downtime, software maintenance cost, and the operational overhead. So we will go ahead with a typical solution overview. So what do we do from a solution overview point of view? So in pre-production, there are a couple of activities even before we deploy, right? So one is basically from, depending upon the different stages of project, you actually make sure you identify those performance issues, starting from your business requirements, building a system to scale to the business needs. As part of your performance testing, you baseline your performance benchmarks. When I say baseline, you would want to start off at some point to say that how the actual system looks like when all the stacks are put in place, including the infrastructure, the software components, and also the configurations. And identify bottlenecks, issues. We'll talk a little more about some of the methodologies and the best practices as we move along. And of course, once you identify the issues, you tune and you optimize it to cater the business needs. And in post-production, why is post-production important? Once you're done testing, in the post-production, you actually make sure that you monitor, get the actual real-time data in terms of availability, do a right amount of performance monitoring in terms of the transactions, accessibility. Of course, your application should be able to scale, and system monitoring, and make sure it actually meets the service level agreements. So going back, looking at the actual data from post-production, it helps in terms of the capacity modeling, so that you take the capacity modeling back to your performance testing to make sure that you model your scenarios and the actual testing to mimic the pre-production scenarios. And as part of your performance capacity modeling, again, you've got to have production performance projections in terms of the number of users, the scenarios, the user base, and so on. And of course, you have an application profiling that helps you to see and identify what the actual problems are, and also predict application infrastructure behaviors. So one other component from a performance engineering is also looking at the infrastructure changes that get into the production when we run into issues. And the infrastructure changes could be adding servers, changing the load balancer settings, as well as your web and applications and the database settings. And of course, it definitely will improve the performance to cost ratio. So all these three components are internally tied, and you can just look at the directions in how we actually use most of these components. And from a framework, performance engineering framework point of view, again, most of us use and have different stages. Here we're going to categorize those things into 4 different phases. One is you plan, you develop, execute, and analyze. And let's look at what we do at each of these individual stages. From a planning point of view, planning is very key for any performance engineering and as well as testing. The performance test strategy has to be very clearly defined with the objectives about what you're trying to achieve. Given the infrastructure stack as well as your performance numbers, what you have to meet from a business transactional point, you got to define your business scenarios, and also make sure that your test environment and the tool setup, which helps you in terms of simulation, profiling, identifying, capturing the memory stacks as well as the CPU, and all the other things are well put in place. And also the test data is one of the key component in terms of your planning, because without the actual test data, or without a data which is as close to as what's going to be in production, it doesn't really have value in terms of your testing. And once you have, you sign off. And as part of your development, you make sure you have a right mix of your business scenario metrics and the user load. So what it basically means is when you have a business scenario, for an healthcare application, the business scenario could be like a lot of anonymous users might be coming in, trying to look at various plans that are available depending upon their income level, zip codes, doctors, prescriptions, and so on. And the business scenario could be a combination of multiple of these scenarios, because every user that comes onto your application might use the application differently depending upon the functionalities that is available. And of course, you create the test scripts. And as you create the test scripts, you want to make sure that you also have some simulators in terms of getting the right amount of data into the system. And you configure the actual tools for simulation as well as monitoring. And one of the parallel activities that you do is the shakeout testing to validate your test scripts at the same time if there are any specific thing that needs to be added to the plan. Again, these two go hand in hand in terms of making sure you have the right scripts. And when it comes to scripts, you always have to make sure that the scripts really mimic the real-time user depending upon how your application is set up. And in execute, before we actually look into the actual full-blown execution, once you have validated your end-to-end functionality, validated your scripts, you got to make sure that the failure and disaster recovery testing is intact. The reason that is important is if in your performance testing environment, if you have multiple stacks. When I say multiple stacks, it's basically having multiple layers of web server, app server, and database, including the firewalls as well as the load balancer. You want to make sure during your load, when one of the stack in your infrastructure is down, like for example, if web server 1 is down and app server 2 is down, what actually happens? What happens to the users that are actually have a sticky session to that particular web server, or a session that is established from a web server to an app server, depending upon the transaction they are doing. You need to define these things as part of your initial strategy, make sure these are working, and then you slowly scale up the load to actually start benchmarking and as well as identifying the bottlenecks. We'll talk about how do we identify bottlenecks and how helpful it would be for the entire engineering purpose. And one of the key things, running tests is probably about 20% of your all effort. Analyzing the test results as you scale up is very key. You can analyze the results at various levels. One is at the transactional throughput layer. The other one is at the mid layer when it comes to the actual sessions, the connections, and the JVM. If it's a Java technology, you got to make sure that your JVM is scalable. You identify those issues, you rerun the test, you tune your system, and then again you publish the results. That's part of your process. So we will look at a total snapshot of, we'll come back to the same Obama healthcare example, and we'll look at what can be done at different layers at individual components. So we have categorized it into 4 different areas. One is the browser analysis, latency testing, web app server monitoring and tuning, and then database monitoring and tuning. So at the browser as well as the latency test, what we do is basically you need to be able to make sure that whatever application or software or a product or e-commerce product you're catering to, it has a very lightweight and thin layer that actually works on any end user. The end user might be connecting via DSL or cable modem or from T1 lines, but then again, it should be seamless to them to keep them their interest vested. So we have to make sure the chips are right. The chips are heavy end where it takes a lot of time to load. And of course, there are a lot of tools for you to analyze the browser latencies. We do the web design analysis, and of course, the HTTP traffic analysis is very key. And end of the day, it's basically the end user experience have to be very pleasant in terms of the actual transactions that happen from the end user. And of course, the load balancer and failover testing does definitely help here in terms of identifying the sticky sessions and how the product behaves at various downtimes. So at the latency, again, we look at the latency and the bandwidth. We do the network analysis as well as the WAN simulators. So WAN simulators, again, simulating the users at different layers to make sure that it's kind of like catering to the actual needs. So at the mid layer, when we talk about web and app application server monitoring and tuning, we actually focus on some of the core product by itself. Again, I'm taking this as an example of the Obama Healthcare, as well as it's built on the Java platform. So memory leaks, why are the memory leaks very key and important? Again, when you have a number of users on your application, you've got to be able to see that the memory is very well utilized, which is basically the actual the heap size that is being allocated, and it kind of like follows a very good algorithm in terms of the GC cycles, and also we identify what the GC algorithms are for that particular implementation. So there are various GC algorithms like recycling, where most of the system force GC happens, but then there is no one GC algorithm that fits every implementation, because it depends on how the classes have been called, used, what frameworks are used, like say it could be the Spring framework and so on. And we also look into the configuration reviews. Root cause, identifying root cause is one of the key things, and we'll talk a little more about how we go ahead and identify some of the root causes. And optimization of resources is very key. What it basically means is you got to be able to get to a point where you got to exhaust your infrastructure horsepower of your web servers, app servers, and the DB, so that it's like more than 80% well utilized without memory leaks, so that you get the full strength of your infrastructure. And of course, identifying objects in GC cycle is very key, which helps in seeing how many of those objects are really recycled and what is the memory that is allocated back to the heap size and so on, which becomes very key. And of course, looking at the threads, sessions, and also if there are any threads hanging and so on. Right? So at the database and level, it's basically we would have to focus on actually identifying the slowest sequels to begin with, and looking at the database parameter to cater to the actual incoming traffics in terms of the share pool size, the connection size, if it is well tuned, if there are any locks which actually takes, and also the round trips of sequels. Again, that could be optimized at a single stack layer. And AWR report analysis provide a very good insight into what's actually happening in your database layer and helps you tune your system. So in this particular example, I want to highlight if this is what it's going to look like in production. I mean, is it always necessary to have this entire stack in your test environment? Ideally, yes. But initially, when you actually begin your testing from an end-to-end point of view, you want to make sure one of the best practices, what most of us use, is the single stack approach. When I say single stack approach, it's basically initially when you begin with, you have all the actual component-wise, it equates to your production environment, but then you don't really need to have 2 web servers or 2 application servers to actually fine-tune and identify and tune your core application, because it actually takes, it gives you a little more focus when you just have 1 web server and a app server to tune your application as such, and it definitely does help you with identifying the areas where more JVM tuning is necessary. So again, if Obamacare healthcare implementers would have actually thought about this upfront and utilize the best practices to do the end-to-end performance engineering, I think we could have avoided all the fiasco that were in the news. And of course, it did leave a lot of bad taste with a lot of people who try to actually register. Okay. So we are going to open up for questions. Whoever has questions, please post them and we will answer them in the order we get them. Okay, so one of the questions we have is, let me read it out. Can you please explain more on the single stack? Why single stack? Okay, so let me go back to my slide, the last slide. So why single stack? So I think I did explain, in case if you want to identify if there is any memory leaks. Again, memory leaks could be done at the unit level even without the stack in place. But then again, from an end-to-end point of view, when you have a lot of incoming various traffics coming into your application, how does single stack help? The main importance of having a single stack is the focus of you looking at one web and application server becomes a lot more important. Unless your application, in this particular example, healthcare, let's take this one application server where you have at least about 50 to 100 users concurrently trying to look at different healthcare plans. So let's say the heap size, the allocated heap size could be about 4 GB and then it has 6 CPUs. But if you do not, let's say, exhaust your CPU and the CPU power to 80% or your heap size to like more than 80%, you really do not know. In this example, let's say with 100 users, you have exhausted your heap size, which is like 4 GB, right? Does it mean that adding more memory to your heap helps you, even though there might be about more physical memory available from a machine point of view? Not necessarily. The reason being is the heap is occupied when, again, the simple rule is whenever the Java code is executed, again, it gets loaded as objects, classes, and the classes, again, loads the respective objects into your garbage collection based on the algorithms. And then once that particular recycling, so the JVM actually knows when to recycle depending upon what's been allocated to it. If it even recycles, it's very key to identify those objects in the GC cycle to see whether they are being really being recycled, and after recycling, is it releasing enough memory back to the heap, and so on. And of course, increasing a memory size does not always necessarily increase the throughput. The reason being is, one is you got to identify if there are any memory leaks. The second one is to see if the right algorithms are set. Then you got to look into like the old gen and the new gen, as well as identify the root cause why it is actually needing. So we have identified objects which are like about 300 MB. Again, is there a scope to reduce some of these objects to a couple of kilobytes? Definitely yes. That's when we look into the architecture, optimize, and so on. Okay. So one of the questions we have, the next question is it mandatory to do all of these areas, or you can start small and add more areas as you progress? Yes, absolutely. Great question. So it is not always mandatory to do all of these areas when you begin with, but then again, we can start small. As I think, as I was just explaining about the single stack, we can start off with just without all of these components in the areas. You can just focus on your JVM. You can just focus on your web servers as well, how the services are deployed. And you can start small, and you can actually have these areas as you progress. Excellent question. The next question. So one other question I have is, does your company have ability to provide project services in US itself with US-based teams, or a combination of teams based in US and India? Good question. So we have ability to provide different models. One is we can do it in US itself with the on-site team, and we can also have a combination of a team where we have US as well as India, or if you want offshore, we have that. So we pretty much have all these models in place, and we have a lot of engagements where we are running on these models. Okay, so the next question. When is it recommended to implement DB caching to improve performance? Again, okay, excellent question. So as part of your database analysis and so on, you've got to focus a little more on what's actually happening at the database layer. Let's say you have search features. One of the search features, based on, I'm going back to the same healthcare example, if you are actually searching for different doctors in different zip codes, right? Your system should be able to, based on how the system is built, you've got to be able to enhance and identify those areas where DB caching helps. Like say, for example, if someone is searching for, let's say, a plan type A, I mean, how many people do search? Depending upon how the actual production happens, you got to be able to keep them in cache for a certain amount of period so that it actually improves the latencies as well as the performance. Maybe the first person who is actually searching, let's say if I'm actually going to search for, let me take an Amazon example. If I'm going to search for a product A, and if that product A is going to be, if you see incoming traffic searching for the same product, keeping the actual DB caching and enabling them definitely does improve your performance. Excellent question. So the next question is, which J2EE performance diagnostics tools do you recommend for 3-tier architect? So there are various tools in the market. Again, the industry has been more focused on using more of the open source tools when we are talking about J2EE, right? And again, it depends. I mean, if you're talking about the Sun platform, which is now Oracle, Oracle has its own JVMs, and also it has something called as JRocket mission control tools, which is again a freeware. I mean, it has a very extensive analysis in terms of tuning your JVMs. It actually tells you, it looks into what's actually happening in your application, how the GC cycles have been running. It also helps you look at the hotspots in your GC cycles and tell you how many GC cycles happened, how many short, how many long, old and young, of course, and tell you what objects were loaded. And if you have to focus on an individual object, it also lets you identify if there are any memory leaks and so on. So we have quite a few questions, but most of the questions are related to the questions which I took earlier. So as we are running out of time, we would like for your questions to come in, and please feel free to reach us out with any of your questions, and reach us out at rita.saran@xoriant.com. And thank you everyone for attending this webinar. Really appreciate your time, and you guys have a great day. Thank you.